Hey, what's up everybody? I'm Adam Castaldo and I'm a power engineer here at Texas Instruments. When you're designing power solutions for high performance products and systems, you're always facing challenges with board space, power efficiency and density, thermal performance, and total solution cost, among many others. And your time for designing systems is important too. You need solutions that are easier to use and design in. All of these challenges are common, usually in applications like high voltage industrial, automotive battery management, and especially in telecom systems that require 100-volt transient protection. To help you meet these challenges, Texas Instruments is introducing the world's first 100-volt synchronous buck converter with integrated FETs, the LM5017. Adding to TI's popular family of non-synchronous high-voltage controllers and converters, the LM5017 allows you to enjoy the benefits of a high-voltage regulator with improved ease of use and a smaller solution size. What's key is that now you do not need external FETs or a freewheeling diode, since both FETs are integrated into the LM5017 package, making this the first of its kind in the world with an integrated FETs operating up to 100 volts with a maximum output of 600 milliamps. As a synchronous buck converter with constant on-time architecture, the LM5017 does not require loop compensation, making your design simpler and making your solution size smaller. In addition to smaller solution size, the integrated FETs and constant on-time architecture also help you to keep your cost of materials lower by reducing the number of components in your bill of materials. A unique feature of TI's LM5017 is that it runs in continuous conduction mode, which means that you can substitute a transformer for the inductor and generate an isolated output for your isolated applications. Let me show you how that isolated output option works. What I've got on the bench here is our isolated eval board with the LM5017 right in the middle, and here's the transformer. And you can see the two isolated outputs, the primary side and the secondary side here. For our demo today, we're using a power supply to feed the LM5017 a high voltage input. On the first of these multimeters, we're showing the input voltage, and as you can see, it's being cycled from 25 volts up to 65 volts. On the second multimeter, we're showing the primary side output voltage, regulated to 10 volts. This is an adjustable output part, so you just set the resistors to set the output voltage. The third multimeter shows the secondary output, and you can see that it's a little bit lower, which is due to the diode on the secondary side. But it is a 1-to-1 turns ratio, so both are going to be in the neighborhood of 10 volts. Now, what you see over here on the oscilloscope is the switch node voltage, and you can see that it's getting taller as the input voltage increases. It's also getting narrower as the on-time decreases to keep the output voltage stable at about 10 volts. So the LM5017 is versatile enough to be used as a traditional synchronous buck or to generate stable, accurate, isolated output voltages as well, giving you the option to design with either of two different topologies. Now you can see how the LM5017 gives you great advantages when designing for high voltage systems that require low voltage outputs with high efficiency and smaller form factors. And TI is working on more additions to this family of products with different output current levels, so watch for those in the near future. To make the LM5017 even easier to use, you could build your designs with TI's WebBench online design tool. You can find more information, tools, and support resources by visiting us at ti.com/industrialpower. That'll wrap things up for this video. Thanks for watching, and we'll see you again next time.